and welcome to the webinar, Evolutionary Microservices Enabled by AxonIQ. My name is Ben Runchi. I'm a solutions architect with AxonIQ, where I help customers find success using the strategies and tools we'll be covering here today. A few items before we dive in. This is intended to be an introductory webinar to give you an overview of how using our technologies, your team can build services that can be easily evolved into microservices when the time is right. We do offer more hands-on training through our AxonIQ Academy that you can find out more about this at our website. Finally, your feedback is extremely important to us. And at the end of the session, we'll provide you with a link to a feedback form. And we'd really appreciate it if you could take a few minutes to fill out the form and let us know what you think. So let's jump in. First, let's cover our agenda. The first thing we're going to do is kind of review some traditional approaches to application architecture and some of the challenges that they can present. We're going to give a vision for the future, how evolving the microservices using a modular architecture, messaging-based communication, and location transparency can give you the flexibility that maybe you're looking for. We'll give an introduction to the technologies that AxonIQ provides to build services. We'll walk through a sample app showing how a service can be built, a bike sharing app, showing how a service can be built, evolved, monitoring using the technologies from AxonIQ. And then finally, we'll actually go through an actual demo of the bike sharing app. We'll have a code walkthrough where we walk through some of the same pieces that we cover in the sample as we walk through the sample app. We'll connect that app to Axon Server as our event store and message routing engine, and show monitoring the application using AxonIQ Console. And then finally, we'll show how we can evolve that from a monolith to microservices real easily when the time is right. All right, so let's get started on this. All right, so if we go back in time to the 1970s, we end up talking a lot about layered architectures. It was conceived back then as a way to, provide the opportunity to put business logic in front of your database that would have all of the data that's important to your system, right? So sometimes this can be referred to as the box cylinder architecture. This was coined by Ted Neward, and really, just as I said, the basic idea is to protect the data in the cylinder with business logic in the first box, and then usually there's another box added further to the right, or to the left, I'm sorry, that handles things like maybe it's your UI, maybe it's your transport if you're building an API. So the box that probably has the highest value in terms of value to your company would be the box in the middle here. And so let's take a look at what typically happens inside that box right now. So, when we get started, you have your blank slate. There's nothing going on inside your box, and you start conceiving what all the concepts are that you're going to be managing, all the data that you need to manage. So at this point, our complexity is pretty low. The modules that comprise our application are quite isolated. They're pretty easy to reason about. We don't have too many complex use cases. But over time, as we add more of those use cases, the number of dependencies between the modules start to increase because we actually have added more of our business logic to this, not just create, read, update, and delete. Oftentimes, this kind of grows unchecked until it finally feels like everything has become interconnected. So if we don't manage this, it begins to impact us in quite a few ways. First one, limiting our ability to add new features. Second, making it difficult for multiple teams to work together, possibly in the same code base. And then finally, handling changing performance requirements. Maybe there's one part of the app that needs to scale up, scale out, or just even evolve faster than the other parts of the app. But this is kind of hard to do when we're dealing with just one monolithic application that has no real approach to managing its dependencies. So oftentimes to deal with this, teams will make the move to microservices. So this is usually done many times by just breaking apart the solution or the monolith into the nouns so you can understand them in detail. But the ironic thing about this is a lot of times that understanding that one noun in detail kind of leads to losing the overall understanding of the enterprise that it serves. So if this is not done right, this leads us down the path of more of a distributed monolith in that services start to develop tight coupling between each other for various situations. You end up with complex chains of calls to deliver whatever functionality that you have. Services, which are not truly independent, they always need data from other services to complete their tasks. And functionality, right? How do you gracefully degrade or invoke logic in other services if they're not present, right? Because the whole point of microservices is independently deployable services, right? Which is the final piece. Can we really deploy a service independently without breaking other services in the app in this architecture or overall enterprise approach? So a lot of times, to avoid the coupling that this causes between services, where everything has a direct call from one service to the next, we look to messaging as a solution. That leads us usually to events, right? Event driven architecture. Hey, how can you notify another service of the change in your service? Raise an event, publish it on your bus, or put it to a queue. So adding the use of events or really messaging to manage the notification of changes between the services, it provides us a certain amount of flexibility. Decreases our coupling because presumably we're coding to more the event contract than having to know where our services are, or are they up or are they down. And a lot of times this is going to lead to mostly independently deployable services. But there's still yet some other pitfalls beyond this, right? So here we talk about events. Well, events are notifications of something changing in the system. What happens if one service wants to request that the state of the system change, and that state is managed in another service? Does it raise an event? Event doesn't feel like the proper term there. Uh, some of our events can become totally data centric, right? So we just end up with the something created, the something updated, the something deleted event, right? So there's no real business value to these events. And a lot of times this ends up bleeding the internal state of whatever data model you're storing that concept as out. So it makes it even that much more difficult to evolve a service independently without knowing you're breaking other services. Now you're forced to evolve events when maybe that really wasn't something that anybody else cared about. Also, in this case, events might be a bolt on to an existing system. So, are the events that you're publishing really showing what's gone on into your system or in that one service, or are you maybe missing some things or some context at that point? Which leads us to the next one. Uh, do the events have any business context, or are you just publishing create, read, update, and delete events? Right? Do we always need to react to every update event? Knowing what was in an event or what was actually changed, the context is kind of lost at times. And then finally, can we still ask for data from another service? How do we do that? Do I need to listen to all the events and build a local copy? Right. And then the challenge is, okay, is my copy still actually representing what the original all the original events intended them to mean? So there's opportunities to improve on this as we go forward. So Um, those are just some of the things from a functional perspective. Now, if you add on all the other pitfalls for microservices, all the non-functional things you need, such as multiple deployments, multiple databases, observability, distributed tracing, these types of things, if you don't already have them in your platform, this is a lot of times going to severely limit your ability to deliver both a microservices architecture and the business functionality that you need to deliver. So if we take a step back and we think about the beginning of either a great new business idea that you have, or even just an existing app that has big expansion plans, a department level app that you want to scale to enterprise heights, there's that urge to immediately start with microservices. But getting the boundaries identified early on can be quite challenging. Like where really do we break this apart? Along with this, you're also forced upfront to deal with all those infrastructure requirements we talked about. So taking out so many challenges at once can sometimes lead you to wander the microservices desert, right? Looking for a way to deliver that business functionality that you need while also trying to scale your environment or all the technical needs that you have to be able to troubleshoot it, manage it, and give the support to the business that they need. So rather than taking the microservices path to begin with, We recommend starting off focusing on modularity inside of a monolith, right? The goal here being that we want to make sure we can find those boundaries, those proper boundaries within what we're building. These can then be refactored easily and cheaply to find what really needs to be a service on its own. Usually, the drivers behind this are non functional, things like processing needs, scaling needs, team size, team independence, how fast something needs to evolve versus the remainder of the app. And so we can continue to do this as we learn more, all the while evolving the right modules of our monolith to become their own services. But how do we do this, right? How do we go back inside that box that we talked about and stop all those lines from uh, being created, all the dependencies between all the different modules that we have, right? How do we stay loosely coupled and highly cohesive? We do this by using messaging as the backbone for our communication between the components. Typically, when developers hear messaging, they're thinking of events, right? We talked about that earlier. Events, we love events. They're great, tell a great story. Can be used over and over again to answer questions, see what's happened. Maybe even we can feed it into something to help us predict the future. That would be great, huh? But like I just said, they represent things that have already happened, right? What if we need to make a request to change the state of our system? Excuse me. For that, we need a different type of event or different type of message. A command, right? Commands play a big part in allowing our components to interact with each other. They provide the ability for one component to express the intent to change the system and for one component to handle that. And upon handling that command, hey, we'll generate an event. That being the notification that something's changed in the system, and that event represents that change. So, and then finally, we have the question of how do we subscribe to all events, or how do we get data from other components of our on the network? For that, we have queries, right? You don't need to subscribe to every event, build your own view of it every time. Oftentimes, there's a query that you could possibly provide that can be uh, use a query message to access this data, get that state back, and be able to go along your way. If it's really important or you need to have your own view of it, hey, that's when you'd start consuming all these events and start producing a read model or projection of your own. So if we take these three messaging concepts, we can see we're able to handle state changes, notification of state or request for state changes, notification of state changes, and hey, can I get the current state of the system? Pretty much these are the three bedrock pieces that we need in order to do messaging for any application, any distributed application, and have them effectively, all the components continue to communicate with each other effectively. So in essence, the messages a system defines become its API. So kind of keep going along this path. Messages describe the behavior of a system. When we have some events that have happened, again, that's our state. And a user does something, we turn that into a command. User's asking for it to change. If the command is accepted, hey, a new event's raised and the state of the system has changed. We have some existing state again on the next line, and the user asks for some information. Maybe it needs to view a summary of all of the purchase orders in your system. We can execute a query with a purpose-built query to answer that question. That's the response. And finally, events that happened in the past give us some state, which maybe we have a timed event or a deadline, something that, hey, if we go past this 20 days later, nothing's changed, we need to raise another event. And when that event gets raised, it could produce a command that gets sent to change the state of the system. So again, these three pieces, commands, events, and queries, provide a pretty good foundation, very good foundation, to be able to build your system. So now that we have our type of messages defined, how do we easily route these between our components? Well, we're going to do that using a message bus. If we focus on using messaging through a message bus to manage the communication between our components, it leads us to location transparency. This is one of the key pieces for being able to take a module within your monolith and be able to spin it off and have it become its own microservice. If you have to know how to find something on the network constantly, you're going to always have to go back and update your code to make this happen. So once we go down this path of achieving location transparency, this allows us to break our monolith when the time rises and we have the need to scale one or more of those components out. Doing this, we end up with deployments that, regardless of where they are on the network, they all look the same to our components. So the basic concepts here that we need to take away are: a component should neither be aware of or make any assumptions about the location of a component it interacts with. It could be living in the same process, it could be living cross-process, right? A message bus provides us this location transparency. And again, location transparency starts with good API design. If we don't have those messages well defined, the commands, the events, the queries, we're not going to be able to achieve location transparency to be able to run our service or the components of our monolith as microservices. Sorry. So when we take this, put it all together, it starts to look a little bit something like this. Commands being handled by command handling components at the top of our picture. This is enforcing our business rules and creating events about the concept our system is managing. Events being handled to either create query models of these concepts for use by APIs or UI, export, whatever have you. Possibly, we might even have to interact with an external system through an event. And finally, queries, which are providing access to the query models that we talked about. Add in the message buses that we were just describing, which would live here. We have a command bus for sending and delivering our commands, along with a query bus, which allows us for sending those query messages for our data to be requested. And then finally, adding in location transparency. Here's where we would put the logical boundaries for location transparency in our application, giving us some feeling of, hey, where could we scale up, scale out any one application when the time becomes right? If even one concept needs to have different microservices to help manage it. So how do we do this at Axonic? Well, first, we have Axon Framework. This is an open source framework to build message-driven applications on the JVM. Easy integration with Spring Boot, and it provides all the messaging abstractions that we've talked about here for location transparency, the message bus, and it has first-class citizen being commands, events, and queries to be able to do those, to be able to build your system on those. When the time's right, you need to extend your application to be more distributed and have a more higher performance event store. We have Axon Server. Gives us distributed message buses for routing of commands, events, and queries to intended destinations on the network, right? Connecting application frameworks or Axon Framework apps requires zero configuration with Axon Server. It provides a purpose-built event store for event sourcing, and this is free for non-clustered usage. So just a single standalone instance of that Axon Server will cost you nothing. And then to monitor an application that's a little more distributed, takes a little more work in figuring out where you are with things. For that, we have Axonic Console. This provides some monitoring and management of your Axon framework-based applications. So let's jump in and take a look at a simple app that for bike sharing that can help us walk through showing how these concepts fit together, and then eventually showing how we monitor them. So to start with, let's start with the concept of a bike. Add in the behaviors which manage creation and sharing of a bike. So register, checkout, return. These become our commands. Those commands, when handled by the bike, raise events to represent the resulting changes. We have these events: bike registered, bike checked out, bike returned. These are going to be stored in our event store in Axon Server for future use, possible future use, and also right away here to be processed by our event handlers that are going to create query models to give us some purpose-built views to represent the status of a bike in our inventory. Right? So we have a bike status. We have some queries defined: find a bike, list the bikes, that'll be able to show us, be able to provide access to what is in the system. And then to provide access to our functionality, we're going to make an API that sits in front of it. And this is going to use our command bus to send commands and the query bus to request data. And then finally, to get this up and running, to take our concept and actually make it happen in real life, we're going to put these components together in a Spring Boot application that utilizes Axon framework and connect it to Axon server. So here's what a monolithic application would look like. We have some different components in here. We have one concept we're managing, bike, but we do have the commands side of things. We have the query side of things. We have our events being handled. So I'll have the opportunity there to start with something that can be evolved later on, which is what we're going to talk about now. So let's say our bike sharing product is enjoying tons of success, but our app's showing some signs of stress, and we need to figure out how do we scale this properly. So if we take a step back and go to that diagram where we put everything together, we have our location transparency boundaries. So if we take that idea of where those boundaries are and apply them to our app, the application we just built, we end up with something that looks pretty much like this. So you can see we're able to scale out or run independently our command handling and event production. We're able to run independently the consuming of those events to build bike status and handle those queries. And then we're also able to scale up the API side of things independently of the other two as well. So it gives us a lot more flexibility. And then with the message buses, we're able to route things on the network. So every one of these boxes would be connected to Axon server, either for the purposes of the event store or for handling command routing, query routing, or just processing of events. So now if we stop and think about what does it take to manage and observe an application that's a little more complex like this? Well, we have, sorry. Yep. We have our monitoring needs. We have Axon frame. We have the application configuration. We want to know, hey, what version are we running? Because we might be running in a distributed environment. Do all of our applications use the same version, right? Or are they slightly different? And is there an impact to that? What message buses are configured with which applications? Are our event processors running, right? Are we actually consuming those events to build those query models that we talked about earlier? How long is it taking us? Like, what's the performance of our application to handle our messages, commands, events, queries? How long is it taking us to write to our event store? Is that a bottleneck, or is it performing as we need, right? How long is it taking event handling latency? How long is it taking us to get events out of our event store? And then finally, distributed tracing. How do you follow a message that started as a command that turned into an event, or that produced events? Those events are being handled, and then those events are being queried. How do we show all this happening, right? We need a little bit of distributed tracing. So the monitoring tools we have out of the Axon framework provides distributed tracing. It has an open telemetry component that you can use. So this would provide APM data that would be able to visualize message flows across all the Axon clients. This requires you to use another tool such as Jaeger or maybe Datadog, or another tool that can give you that visualization that can consume the open telemetry data. We have metric endpoints, Micrometer. These are enabled through our Axon Micrometer dependency. This is a Prometheus endpoint that can be scraped and provide easy integration with any of your existing monitoring tools, such as Datadog, Grafana, Sumo Logic, things like this. Provides all the monitors and gauges that you would need to monitor a messaging application. And then finally, if you don't have some of the more enterprisey level things we've just discussed available, we have Axonic Console to help get you started, and also probably give you even a few other insights that maybe are a little harder to glean from the previous two that we discussed, right? So we can have Axonic Console dashboard providing real-time insights into your application, shows again that application configuration, right? What framework versions are you using? What buses do you have configured where? We have messaging metrics involved here and some visualization of them. monitoring and management of event processors. You can start your processors. You can auto balance them, and then trigger event replays. And then finally, we also have alerting that's been added in as well. So now we've talked about what an application looks like, what the tools are there to monitor it. Let's get a little bit further down into what constructs Axon Framework provides to enable building these applications. So the first piece we're going to start with is command and command handling. So if we take our putting it all together slide and focus on the command handling components, we see there are two aspects. The first is handling those commands, and the second one being the creation of events as the result of handling the command, if it was handled successfully. So to do this, we have a few concepts that we need to cover, right? We have a command, right? We talked about this earlier. It's just a request to another component to change the state of the system. The command message itself, this is just the request. So this would be basically the contract that you're using. The command model, think of this as an aggregate or the concept that you're looking to manage. In this case, that bike we talked about, that would be our aggregate here. And we have the concept of the aggregate annotation that Axon Framework provides, that you can put on your aggregates to help to create them as command handlers and enforce your business logic. Getting onto that, I already got ahead of myself. Command handlers indicated by the use of the @command handler annotation. This is where you'd actually put your business logic, and if successful, this is where the events would be produced. And a second. And then finally, command routing, right? How do we know when I publish a command on the event bus, where is the command handler located? The command gateway command bus will work together to figure out where it needs to route your command to help it be handled successfully. Moving on, we talk about event handling and those query models. So again, an event gets produced by command handling, gets put to the event store. We want to pick that up and build a purpose-built view, or possibly even talk to a third-party system or do some other action on the other side or in another event handler to make things happen. For this, we're just going to focus on the event or read models at this point in time. So events and event handling concepts, like we talked about, an event is notification something happened. It's immutable. Event sourcing handlers, these live on your command model on those aggregates we talked about. So they're going to be used to rebuild the state of that aggregate from events. Event handling components, these are just classes that have methods that handle events and help build your query models, read models. And then event handlers, indicated by the use of the event handler annotation. And then finally, talking about query models here, or read models, these are just models optimized to answer a specific set of questions, focused on delivering specific information, like we said. Usually you're going to denormalize things, right? Table per view. We're trying to avoid complex queries, complex joins here if we can. That's one of the intentions. And they are created, updated by the event handlers. And all while you're doing this, you want to consciously optimize for performance and storage. Performance being, hey, how can you avoid lots of joins? How can you make sure that it's being returned quickly and fast and as quick as possible? And then the storage, maybe how you store it. In other words, what type of storage works best for you? Is it a relational database? Is it going to be a document storage? What exactly are you looking to get out of your view models to make them meet your needs? So, all right, and then finally, queries and query handling. Pretty simple. Basically, you send a query on the query bus, query handling component picks it up, executes the query against the read model, and returns the value or returns the data, right? So we have a query, request for data, the query request itself, again, a contract, query response, could be a contract, query handlers that actually handle it, and then query routing, query gateway, query bus to help when a query is sent, get it handled by the proper query handler. All right, so let's get into a little bit of a demo application. So taking our register, our bike sharing application, let's just take one use case, the register bike use case. So we're going to see we have from the API, we're going to produce a command. That's the register bike command. It's going to be routed through the command bus, or through the command bus, sorry, command gateway, to the bike aggregate, who's going to handle it. It's going to produce a bike registered event stored in our event store. That will be picked up by an event handler to produce a bike status view, and then we'll be able to view that using the list bikes query that will be sent from the API. So with that being said, hey, let's take a look here at this demo. So the first thing I'm going to do is I'm going to start an instance of Axon server for my application to connect to. And we can take a look at that real quick just to prove it's running. Might take it a second just to come up. Come on, here we go. Yep. So we have an Axon server running. It has an event store. It's a default one right now. And we'll start our application and get it connected to this. So let's start the proper instance of it. Just a real simple one. And show it. Should connect here any second. Let's see it pop up. There it is. Once it's there, you can see I didn't have to do any. I'll show you right away. It's able to, just using the framework, identify what commands it offers, what queries it offers, and what event processors that are there processing events for us. So right away, we're able to see, and then we only have one instance of it. So let's go through and create a few bikes for ourselves. So I've got just a simple HTTP request here. So we generated some bikes. So let's list those bikes. All right, list all. So here we can see we have about 20 bikes, I think I make. 10 bikes, 20 bikes. So let's check the status of that one bike. Here, let's bring up my requests. So we're going to check on that bike for ourselves. Yep. Check on the bike. Here it is. It's available. It's in Rome. How about let's check that out? Check out our bike real quick. Check it out to me. So let's check on that bike now again. You can see it's no longer available. It's checked out to me, brunch in Rome. And now we're just going to return this bike, and we're going to ride it across the Atlantic, and we're going to return it in Toronto. All right. So let's take a look at that bike again. Yep. So it's now available, and it's not checked out by anybody since I returned it. So if we kind of walk through the code to make those things happen that we just did there. If we take a look at the bike controller, scroll up to the top, you can see we generated some bikes. So here we had the register bike command that's being produced, and it's being sent on the command gateway like we just discussed. That is going to be routed over to our bike aggregate, which has that aggregate annotation that we talked about earlier. We have a command handler here for register bike. We don't have any rules right now, nothing too sophisticated here for registering bikes, but we raise a bike registered event, giving the bike ID, what the type was, all the information that came from the command. And we're handling that inside the aggregate to give our aggregate its state. So we take the bike ID and store that. And then we also store whether or not we're checked out right now. So right now we're just doing with a simple is available flag. This is raising this event of bike registered event, which then is being handled by our bike status projection. It has a processing group of bike status like we talked about just a minute ago. And you can see we have our event handler, bike registered event, that's just creating an instance of a bike status, which if we jump over to that, it's just a simple entity that we're storing things, bike status, with a few properties that we have that we get right from the beginning. Then we save it, right? And then for a query, we'll come back to the controller, because this is where we wanted to see, we want to show being able to execute a query. You can see there's this one here, the get, hey, can you just find me this bike? So we have a find bike status by ID query that we send to the query gateway. And in our bike status projection here, we've actually combined them together to do just both create and provide query access. But you can see we have a query handler here that allows us to find our bike. And if we wanted to find all, we can also do a query handler that just takes a query name. And we can take a look at that real quick right here, where we just list all the bikes, where we just have a constant that's telling us to find all query. We don't have there's no query or parameters to be passed, but we are returning just multiple instances of the bike status class. So you can see the controller really is the one that's using a lot of the message buses to send data around or send requests around at this point in time. Those requests, commands, or queries are being handled by the proper components that are all right here. And then to make things easy for evolving long term, we recommend putting all of your events and commands and queries and your projections or your read models, the definition of them, into a distributable component, so that this becomes like your contracts that you're able to distribute to other applications, or other applications could take this dependency on you. So, all right, well, with that, let's take a look also, since it's running still. We can just take a look a little bit at Axon server here. You can see monitoring, some basic monitoring for telling what's happening. You can search for events. So here's all the events that we've produced so far. Let's go to live updates, last hour. So we haven't produced too many. We just got 12 because we created a few bikes and then checked one out and returned it. You can see how many of each command have been dispatched, handled, and then distribution. In other words, which nodes, which components on the network it's routed them to. We have the same thing for queries here. And then events, we have event streams and then scheduled events, but this is not anything we're working on right now. So you can see Axon server is able to get you up and running very quickly to be able to produce an application like this without a whole lot of extra effort. You get all your message routing and event store in one. So, all right. So then now we've done some work here on this. Let's go take a look at AxonIQ console and see just how we are monitoring our application. So AxonIQ console is kind of your one-stop shop to get started with monitoring with Axon framework applications. If we want to go back to here, let's log out and I'll log in. Come in, you can sign up. You can with one of a few different ways, username, password, or one of the other integrations we have. All right. So I have the concept of workspaces here. So this is my sample demo workspace. And within that, you can have different environments. So if you want to create a new workspace, you would just use this to create the name, give it your first environment name, and create the workspace. I already have one created. So we're just going to jump right into sample demo. And you can see I go into my local one. I have already my bike sharing application set up. But if we wanted to connect a new app, it's as simple as taking the proper dependency, giving it a name, if you want it to be named different than what the Spring Boot application name is, copy the properties that or the YAML values into your properties or YAML file, and you're ready to go. So if we take a look at my application right now, you can see I have those already set up here. So that's what's allowing me to connect. If we take a look at what we have, I only have one application. If we get into a few more details on it, we can see some basic information, how it's performing, what might be some things to take a look at right away, what our configuration is. Again, talking about, hey, what are the the buses we have set up? How are they configured? What are we using as our event store? What are the serializers? Some basic application statistics that are available for us. We can get further into processors. Oh, sorry. Want to also show versions here. Shows you what version of components you're using to help troubleshoot things. And then if we get into processors, we can see it can show us, are we claiming everything that we need to? Are we processing all the events that we need to? So we have 100% of the stream is processed. Latency, how long it's taking us to do anything. Again, this is not anything I have running, anything running through it at the time. We have the ability to manage our processors, so we could pause it if we needed to. We can restart them. And we could even trigger a reset if we wanted to rebuild a projection because maybe we have some new functionality we've deployed. So we can see each one of our event handlers, how they're performing. And again, some other statistics about those. We have the same information around aggregates, around the bike. You can see how the different commands of the bike are being handled, how long each one of them is taking, broken down by different steps that it requires. And then finally, let's take a look at our monitoring here. We have some out-of-the-box conditions to keep you informed of, hey, do you have anything in your dead letter queue? Do you have anything taking a long time? The commit latency. Are you missing events? In other words, you don't have enough all of your segments claimed. Getting into a little bit more advanced concepts here with Axon Framework. But these are out-of-the-box configurations. You can override them. And then for sending you notifications, we have our integrations. Right now, Slack is the one we offer with PagerDuty, webhooks, and email all coming very soon. So, and then if you have an Axon server that you like to connect, you can connect that here as well to give you an overall view of what your environment looks like. So, all right, well, now what we're going to do is we're going to restart our application, but I'm going to start with a slightly different profile here that generates data for us. So I can show you a few other things happening. So this will give us some action, not just me clicking, but sending HTTP commands. And we'll see this connect to our Axon server again. Let's come back to overview. Let's see, we have bike sharing. But now, since I have it running, it's constantly producing, checking out bikes, doing different things. You can see our CPUs climbing, moving around. We have some things happening for ourselves. We can go take a look at the event store. If we go to live updates now, you can see it's producing some data. We now have 100, 200 events. Our commands, we have many more event commands being routed. So you can see that. Same thing with queries here as well. But many more of those are going. And if we go back to the console, you can see our process. If we go take a look at our processors, you can see the time of them is actually dropping because we're doing more and more here with it right now. So it's got some actual action going on with it. So, and the graphs would change appropriately if we read them long enough. All right, so that gets us going, but let's start a second version of it so we can show just, hey, how would we, of our event processor, so we can show just what this ends up looking like. So you can see now if we come to applications, this will eventually turn to 2 here. And if we come to processors, I'll make sure my processor connected. Yep. There we go. So you can see we have 2 processors now. And through automation, I've set up balanced segments. And how often do I want to trigger the automation? I want it to be on a node connect or disconnect and every 10 minutes, because I want to make sure that I'm processing, evenly balancing my event processing across both segments. And so it's a great way to be able to, if you're not using Axon Server, to be able to do this. In Axon Server, we can do the same thing. If we come down to Overview, click on Bike Sharing and Event Processor, the one thing that, and then here we'd have the ability to set our load balancing strategies at the time. So, yep. All right. So finally, the last piece that we wanted to show here today is the ability to go from a monolith to microservices. So I'm just going to stop this second one here just for the time being. And then we're just going to run I have a script here that is going to move to microservices. Oops, I just called it microservices. Move to microservices. That is going to copy all the relevant Java classes from the different folders I have into some pre-built structures of applications. One for the API, one to handle those commands that we talked about, and another one to handle queries and projections and building the projections. So if I run this, you'll see here, we close it. There we go. You can see that we get the bike controller arriving for us. We get the bike moving into the command handling piece. And then for queries, we get our bike status projection there. So now if I start those services, just going to start them. And the other thing that I've already done ahead of time is I've already set them up to connect to Axonic console. So now that these are all starting, we'll kind of let them start up. And we'll start to see them show up here in, come on, there we go. There's the command. We still have bike sharing running. Here's the query. And we should get one more, the API. How's that one coming along for us? Did it start? Start this one. There we go. Sorry for the delay. And come on. Nope. Oh, I know. My existing application is running on this port. So let's stop that. And we'll just start this one. Sorry. Something I forgot. All right. So now you'll see that bike sharing disappeared and bike sharing query is here and bike sharing command. All right, and then we'll see the API arrive and we should see them all show up back here in console. So they connected. Here you can see bike sharing came offline, bike sharing query is running and it has claimed 100% of the segments. And here it says segment claim is not equal to 100%. And that's because back here, I still have bike sharing itself. I turned it off. And so it hasn't claimed any of them. So, but we'll clean that up here in just a second. So you can see now, if we jump into bike sharing query, we're still processing everything we have. And we can come in and remove the one application for bike sharing because it's no longer something that would be running. If we come back here now, you can see it disappeared and we don't have our warnings anymore either. So we've moved from our monolith to our microservices here, just by copying this code, is what we have. There's a few little dependency, or not dependency, but deployment concepts that maybe we need to talk about. I needed to run it on another port, but that's just fine. We can get rid of that or handle that in the future. That's pretty easy to do. So taking all this into account, go back to our presentation here. There we go. So hands-on lab, you're able to download that, take a look at it. So that's all we have for you today. The one thing that we'd like to tell you about is AxonIQ coming up at the end of September here in Amsterdam. It'll be at the Heineken Center. 2 days, opportunities to hear some great talks about people building microservices using Axonic technologies, Axon server, hands-on workshops, and the ability to just meet other people that are doing these same things that you might be doing and gain insights, hear what they have to offer, and meet a lot of industry experts at this. Our CTO founder, Allard, will be there. We have a lot of other great speakers as well that should be able to give you pretty good insights to all things events. So, all right. And with that, just a few list of resources that we also have. The console that we walked through, the academy that I mentioned early on, the Axon Framework Reference Guide, our docs. We are eventually moving away from the reference guide located at docs and moving it over to the library. That's going to take a while. And then if you have questions, we have the Discuss platform where our solutions engineers and the product developers are out there constantly answering questions along with the community, people such as yourselves that are able to ask and answer questions as well. So, all right. Well, thanks for attending. And you can find the survey at this link, or it'll be arriving in an email after the webinar completes. So thanks for your time and have a great day. Thanks.